catastrophe is already unfolding, a slow-motion disaster scripted by the very heart of our solar system. This is not a story of a sudden impact or a quick war. It is the inevitable biography of a planet, a narrative written in the laws of physics and stellar evolution. The countdown to an utterly unrecognizable world began the moment Earth finished its formation, and the timer has been ticking down through the immense silent corridors of deep time.
The vibrant, living planet we know is on profoundly borrowed time. We often fear existential threats from space, a rogue asteroid, a nearby gamma-ray burst. But the ultimate end will come from our seemingly benevolent source of light and life itself. This is the great cosmic irony of our existence. I'm Alistair, and on Winds of Thought, we're embarking on the ultimate thought experiment, a voyage across an ocean of time. What becomes of our vibrant blue and green world 1 billion years from now? We're about to traverse a timeline so vast it completely defies human intuition. A journey to witness the final slow-motion act of Earth as a living, breathing planet.
Today, we project the unimaginable future of our home, deliberately stripping away human influence to see the relentless, impersonal natural forces that will ultimately reclaim, reshape, and redefine our world. This journey will reveal a planet transformed beyond all recognition, where every familiar landmark, every climate zone, and every biological kingdom we know and cherish will be erased, reworked, or obliterated. The real haunting question that will guide us is, will anything at all cling to a desperate, tenacious existence in the face of a changing sun? First, and most importantly, we must begin with a crucial disclaimer. The visions we'll explore are grounded in the best, most robust principles of planetary science, geology, and stellar physics. But we must humbly acknowledge that 1 billion years is an abyss of time. Our entire recorded history is less than a blink, less than a single heartbeat in this immense geological scale. Therefore, we are sketching a scientifically informed possibility, a narrative carefully built on the logical extrapolation of known, observable processes, not a fixed or certain process.
The first great relentless driver of terrestrial change is the very ground beneath our feet. Earth's tectonic plates are engaged in a perpetual slow-motion dance, a colossal conveyor belt of crust driven by the planet's fiery, churning interior. This magnificent process, unique in our solar system for its persistence and complexity, is the master architect of continents and oceans. In the mere geological blink of the next 100 million years, this endless dance will redraw the world map completely, rendering our current atlases obsolete. Africa continues its steady, irresistible northward push, destined to collide catastrophically with southern Europe, heaving up a colossal new mountain chain that could dwarf the Himalayas. Simultaneously, Australia completes its long journey north, merging forcefully with Southeast Asia. Meanwhile, the Atlantic Ocean continues to widen, pulling the Americas farther from Europe and Africa.
This continental rearrangement, however, is merely the prelude to a grander unification. In roughly 250 million years, this global drift converges the planet's scattered landmasses into a single, staggering supercontinent. For our narrative, let's call this
Life on the new supercontinent faces a harsh, unyielding reality. Inland regions, far from the moderating influence of the sea, will become scorching, hyper-arid deserts. Surface temperatures could routinely hit 55 degrees or more, creating environments profoundly hostile to most complex multicellular life. Habitable zones for any remaining land animals would be squeezed to the narrow coastlines and the damp polar fringes. But this dramatic rearrangement of the planetary chessboard is just the opening act in a much longer, more profound play. The most significant and irreversible change is quietly brewing 150 million kilometers away, in the furious, dense core of our parent star. Our sun is not the constant, stable companion we perceive. As it fuses hydrogen into helium, the accumulating ash increases the core's density and temperature, causing the nuclear reactions to accelerate slightly. The inevitable, inescapable result. The sun grows steadily brighter over geological time. Its luminosity is not a fixed setting, but a dial slowly, irrevocably being turned up.
Consider this pivotal fact. Right now, the sun's radiant output increases by about 1% every 100 million years. It is already brighter today than when microbial life first emerged. In 500 million years, it will be significantly, detectably hotter. This incremental extra energy floods Earth not as a sudden shock, but as a creeping, insidious atmospheric pressure, like gradually turning up a furnace in a sealed room. This extra power supercharges the planet's own long-term climate regulator, the magnificent and delicate carbonate-silicate cycle. This cycle is Earth's natural geological thermostat. Here's how this vital planetary cycle works. Volcanic eruptions and oceanic vents continuously emit carbon dioxide into the air. In the atmosphere, the CO2 interacts with water vapor to form a weak carbonic acid. This slightly acidic rain falls onto the exposed continental rocks below. The carbonic acid then chemically reacts with silicate minerals in the rocks, breaking them down in a process called chemical weathering. This reaction forms dissolved ions, like calcium and bicarbonate, which are then swept away by streams and rivers, flowing across a map of the continents and eventually emptying into the vast ocean.
Once in the ocean, marine organisms, from tiny coccolithophores to massive coral reefs, use these ions as building blocks to construct their shells and skeletons, which are composed of calcium carbonate. This brilliant biological process pulls carbon dioxide out of the atmosphere and stores it in solid, mineral form on the seafloor. When these organisms die, their calcium carbonate shells and structures settle as a gentle rain onto the abyssal plains, forming thick layers of sediment that over eons compress into limestone and other carbonate rocks. Finally, the great tectonic conveyor belt subducts this oceanic crust. The CO2 is released once more through volcanic outgassing, ready to begin the majestic cycle again. It is a beautiful, self-balancing planetary thermostat that has maintained habitable conditions for life for billions of years. However, a brighter sun disrupts this ancient balance with devastating, mechanistic efficiency. The increased surface heat and associated higher global rainfall dramatically accelerate the chemical weathering process on land. Carbon dioxide is now pulled from the atmosphere at a much faster rate than volcanoes can possibly replenish it. Consequently, atmospheric CO2 levels begin a long, irreversible plunge toward critically low levels. And this quiet geochemical shift spells inevitable doom for the vast majority of Earth's plant life, the very photosynthetic foundation of the complex biosphere.
Plants are fundamentally reliant on atmospheric CO2 for the engine of photosynthesis. Most trees, grasses, and agricultural crops, over 95% of plant species today, use a less efficient form called C3 photosynthesis. As atmospheric CO2 dips below a critical threshold, these C3 plants can no longer produce enough sugar. They will perish globally. Only a small, hardy fraction of plants might hold on. But even these resilient survivors are living on borrowed time. The collapse of the global plant kingdoms triggers the next great tragic unraveling. Herbivores face immediate starvation. The carnivores quickly follow, a fading of the world's noise and color. Concurrently, atmospheric oxygen levels begin a parallel, deadly crash, falling to a tiny fraction of today's life-sustaining abundance.
The era of complex, oxygen-breathing animals will close, not with a sudden bang, but with a slow, desperate gasp across the planet's final forests and plains. Now, we enter the final, most devastating phase of Earth's living history. The brightening sun, now approximately 10% more luminous than today a billion years into the future, turns its full, unforgiving attention to Earth's last great reservoir of life and climatic stability, its oceans. The increased solar energy massively accelerates evaporation, filling the lower atmosphere with immense, suffocating quantities of water vapor, which is itself a potent greenhouse gas. This creates a thick, insulating blanket around the planet, trapping even more infrared heat. Global average temperatures soar, potentially reaching a lethal 50 degrees or more. A critical climatological threshold is crossed, and a runaway greenhouse effect begins to take hold, a positive feedback loop from which there is no natural return. The oceans, under this sustained assault, begin a long, terminal process of boiling away into the sky. While this complete evaporation will take several 100 million more years, the outcome is thermodynamically certain. Earth will ultimately lose all of its surface water. Our blue marble transforms irrevocably into a harsh, relentless desert planet. The once temperate mid-latitudes become scorching, windswept badlands under a permanent haze.
This ultimate loss of surface water has a further catastrophic geological consequence. Liquid water acts as a crucial lubricant for the tectonic system, facilitating the subduction of oceanic plates.
Earth becomes a dead rock, geologically stagnant and biologically silent, a tombstone orbiting an aging star. The final cosmic curtain falls with the death of the sun itself. In about 7.6 billion years, it will undergo a profound and violent transformation. It will swell into a red giant star, swallowing the inner solar system. Sun-like stars are remarkably efficient destroyers of their inner worlds. The sun's bloated outer layers will likely engulf and consume Mercury, Venus, and almost certainly our silent, barren Earth. The sun will shed these layers, creating a beautiful planetary nebula and leaving behind a fading white dwarf, a celestial tombstone for our solar system. But that very omission reveals the most fascinating and hopeful variable. Our story does not have to end with the planet's finale.
Human ingenuity, imagination, and technology, if they can survive and advance over these almost inconceivable timescales, possess the latent potential to rewrite this entire narrative. We might become active stewards of the planet's climate on a geological scale, find celestial engineering solutions to adjust Earth's orbit gradually, or become a truly interstellar species, spreading life and consciousness beyond our cradle. The cosmos, in all its vastness and with its billions of other worlds, represents our ultimate potential home and our salvation. This scientific vision of the far future is not just a forecast of an ending. It is a canvas of profound possibilities, painted by the immutable laws of nature. It challenges us to think not in years or centuries, but in epochs, and to consider our role not just as inhabitants of a world, but as potential custodians of a legacy that could span stars. If this journey through the abyss of deep time expanded your perspective and made you think about our place in the universe's grand timeline, please let us know by giving this video a like. It truly helps our channel Winds of Thought continue exploring the biggest ideas that shape our understanding of existence. For more profound journeys to the edges of knowledge and imagination, make sure you are subscribed. Thank you for thinking deeply with me today.